Welcome to the video. In this video, we are going to do a quick summary of the circular charge. Now that we've had some experience with this circular charge distribution, we can summarize by saying that no matter how the circular arc is oriented, the electric field created at the center of the arc can always be obtained by first drawing a line of symmetry that divides the arc in two even parts. If the original arc has an angle of theta, then now we have two angles of equal size, each with 1/2 of the angle theta. The direction of the electric field created at the center of the arc will be along the line of symmetry. And if the charge is positive, like shown in this diagram, then the direction of the field will be away from the charge. And if the charge is negative, the direction of the field will be along the opposite direction. For the magnitude of the field, we first will have to calculate the charge density, which will be given by lambda being equal to total charge divided by the total length of the arc, where the length of the arc can be obtained by the definition of the arc length. And in that equation, the angle theta is just the angle extended by the arc. The magnitude of the electric field can be obtained by doing this integral. Notice that in this integral, the k, the lambda, and the r are all constants and can be moved to the front. The integration is from negative 1/2 of lambda to positive 1/2 of a lambda. And this is because in the diagram, we have adopted the polar coordinate system. By now, this is an easy integral, and the integration is straightforward. And here, we're going to apply the fact that the sine function is an arc function. And therefore, that sine of negative 1/2 of lambda will be equal to the negative of sine of 1/2 lambda. And together, we have twice of sine of 1/2 lambda towards the end of this expression. At this point, we can plug in the expression for the charge density lambda. And let's make a better organization out of that, which will give us the final expression for the magnitude of the electric field. Notice that in this final expression, that theta at the bottom has to be in radian. And that's just because degree is not an SI unit. But the angle in the sine function can be either in radian or in degrees. And in that case, it is important that you have your calculator set in the correct mode. And this completes this video.